All right, hello everyone. Let's go ahead and get started. I hope everybody had a great weekend. Before we hop into reviewing today's material, just want to talk for a few minutes about what's going to be coming up next week, which is our first exam. So here we are today. It's February 3rd. Doesn't feel like February 3rd, but that is in fact today's date. Next week on Thursday is going to be our first exam. So 1 week from Thursday at 6:30. It's in the evening. All of you will be taking the first exam, hopefully. And that means that we have an exam review session here next Monday. So when you come to class on Monday of next week, I'll be here ready to do some exam review with you. And in order to help you with that, I wanted to make sure that you are all aware that on Canvas, there is a section for Exam 1 down here. Don't worry too much about the Exam 1 sections, this Exam 1 information right now. I will go over this in class next week, make sure everybody knows where they're going and all that fun stuff. So don't worry too much about this part right now. But definitely, if you want to go ahead and get started prepping for the exam, studying for the exam, there's two things that you should take a look at. This is a Canvas quiz that contains past Exam 1 questions. These are all going to be multiple choice, fill in the blank style questions. This is not a graded quiz, it's just for practice, so it doesn't count towards your course grade or anything like that. Just trying to get you used to the kinds of questions that you might see on the exam next week. And then this down here, this coding prep one, is actually going to take you to a repository, just like the assignments in the studios, with a bunch of past exam problems that require you to write code. So you are going to be expected to write small pieces of code on the exam next week. And this repository has examples of problems from past exams that had students writing code. So please, take a look at those when you're feeling ready to start studying for the exam. On Monday next week, I'm not really going to have much planned. I'll do a quick overview of the exam, talk about logistics, so I'll probably fill up, the first 10 or 15 minutes of the time, but then the rest of the time is going to be open to reviewing exam questions, which usually, but not always, means, working through some of these coding prep problems here in class. So please take a look at those ahead of time and come with questions. Come ready to ask me to walk through some examples. That's how I intend to use the time in class next Monday. Are there any questions about the upcoming exam next week before we hop into today's topic? Any questions about that stuff? All right. Not seeing anything. Fantastic. Then let's go ahead and talk about today's topic. Today we're talking about arrays. So this is actually a very, very, very important topic for us. We're going to start just like we did last time with some review questions. I also brought some more practice problems that I hope we get time to work on today. I'm sure we'll get time to work on at least some of them. Let's go ahead and hop into some review questions. And just like last time, I want to point out that I added a link to Canvas just this morning to the review problems that I'm about to go through. So if you want to click on this Module 3 review problems link on Canvas, you can also access the exercises that I'm about to work through and, follow along with me as we review today's topic. Once you get that loaded into Eclipse, it's going to look kind of like this. Module 3 in class review is over here, and I'm starting with the first exercise, which is just some review questions. So I do like to do some general kind of conceptual review questions before we start working on some exercise. So let's go ahead and hop on in. Question 1 asks us, how are arrays created? And there's actually two ways that this can be done. So let me go ahead and start typing some stuff. Let's say I want to create an array of integers. So remember from the prep work that arrays are collections of values, right? Instead of referring to just one integer, arrays allow me to refer to a group of integers as a collection. This turns out to be a very useful thing for us and something that we'll be using a lot. If I want to make an array of integers, the first thing I'm going to type is int. What next? Yeah. The brackets. Specifically, we're going to use the square brackets. That's right. That's absolutely right. So I'm declaring a variable, right? Just like I declare any other variable, except instead of saying, int x equals 7, I'm trying to say that integer array. So this is how I would say an integer array as a type, int followed by square brackets. We then have to give this a name, just like any other variable name, so I'll call it, practice array or something like that. The name is not too particularly important for us. And then I'm going to put an equal sign. And what's next? If I want to create this, so there's two ways to create an array, and this is kind of where we hit the fork in the road. I can either create an empty array, or I can create an array that already has stuff in it, that already has integer values in it. Let's start with an empty array. If I just want to create a blank empty array, it starts out with nothing in it, what am I going to type next? Somebody help me out? 3 letters. There's the first one. New. That's correct. I'm going to type the word new. So whenever I'm creating an empty array, I start with the word new, and then as somebody over here said, I do type int followed by the square brackets again, but this time I'm going to do things a little bit differently. I have to put a number inside of those square brackets. I have to put a number in there, so I could say 10. What does that mean? If I put 10 inside those square brackets, what does that do for me? What does that number represent? Yeah? What's that 10 going to represent for us? The 10 is going to tell us the size of the array. So how many integers this array is going to be able to contain. So I can make this whatever number I want. If I want to hold, 15 integers, then I can put 15 there. But it's up to us how big to make this array. It's also important to understand that once I make this array of size 10, it is forever size 10. I can't decide later that I want to shrink it or I want to grow it. That's not really a thing that we can do with arrays. Once it's created with a size of 10, then it will be that size for the rest of the program. So I can't change it after that. The only place that I can change the size of the array is right here, by telling it how big I want it to be at the very beginning. Okay, let's talk about the other way to create an array. Let's make another integer array. I'll call it practice again. Well, that's not a good name, actually. I'll call it filled array. Since instead of creating an empty array this time, I want to create an array that has stuff in it. What am I going to type next if I want to create an array that has stuff in it? It's not the word new. Anybody know? Yeah, go ahead.
Like squiggly brackets?
Squiggly brackets, yeah. The official name for that is probably a curly brace, but yeah, you're right. It's going to be a squiggly bracket. Curly brace, actually 2 of them, because they come in pairs, right? And then in the curly braces, I'm going to type values. These are the values that I wish for my array to contain. So by the time that this array, or by the time this statement is run and this array is constructed, I'll have 5 values in this array. The values will be 1, 2, 3, 4, 5. Everybody with me so far? Any questions about this part so far before I hop on to the next question? Okay. So, what is an index? Can somebody just give me a 1-sentence description of what an index is when I'm talking about arrays? What do I mean by that word index? Anybody give me a quick explanation? Yeah.
Index is a number that indicates the position of the item in the array.
Yeah, so it represents a position within the array. So if I have 5 things, right, I have to have some way of telling you about which of those 5 things I'm currently interested in looking at or using or doing stuff with, right? So an index is what we use to refer to a specific item within an array, a specific position within an array. You'll hear me use the term index and address kind of interchangeably. I mean, they kind of mean the same thing. The index is an address for each element. And what is the first index of an array? Every array starts with the same index. 0. Good. 0. So this is something we saw a little bit last week. You kind of saw me using 0 a bit more than perhaps you thought was normal. As human beings, we like to start counting from 1. But that's not true on the computer. On the computer, we like to start counting from 0. So instead of going 1, 2, 3, 4, 5, oftentimes we go 0, 1, 2, 3, 4, 5. So that means, right, that this 1 right here is at position 0. It is the first element in the array. The index of that is 0. The first index of the array is always going to be 0. That means that this 2 is actually at position 1. And the 3 is actually at position 2, and so on and so forth. So the index of the array is just an address that tells us about a location, a specific location within the array. Notice then this last question. If I have an array with n things in it, what's the index of the last value? n minus 1, that's good, and we can actually verify that by looking at this simple example. There's 5 things in this array, so the length of this array is 5. There are 5 things in it, but remember we start at 0, so 0, 1, maybe I should make these numbers a little different so it's less confusing, I don't know. So this first number is at position 0, this second number is at position 1, position 2, position 3, position 4. So the index of the last element is at position 4. What element is at position 5? There isn't one. If I try to access an element at position 5 for this array, I'm going to run into a problem. I'm going to get some red text and says, hey, you can't do that. I don't know what you're talking about. There is no position 5, right? Because we start counting from 0, the last index is always going to be the length of the array minus 1. So if my array has 10 things in it, the last index is going to be 9. Always, 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 always. Everybody with me? Any questions on that little piece of info? Okay, so then let's talk about, actually I think I would like to talk about how we access data, right? Within an array. We can actually prove this by saying, let's say I want to access this 10. I know it's at position 0, but what do I type inside the parentheses here so that it'll actually print out that value of 10? What's the first thing that I need to do to access this 10? Anybody know? Somebody help me out here. Or I wouldn't have to use a print statement here. I could even just use a variable, right? First value is equal to. How do I extract this 10 out of here? What's the first thing that I need to say? So the first thing is always going to be the name of the collection, the name of the array itself. But that's not enough, right? I'm trying to get one value. This isn't just one value, this is a collection of values. So that's kind of why it's angry at me right now. It's saying, hey, you can't take an array full of stuff and stick it in a variable that just has one int, right? It doesn't match. So I have to say more. I have to say even more. I want to extract a single element out of here. So what am I going to type after this? Not quite, not the index. There's something else first that we've used before. Square brackets, yeah. Square brackets. You're going to see square brackets a lot when using arrays. The index is what's going to go inside of those square brackets. So if I want to get the 10 out, I'm going to put a 0 inside of those brackets. That says travel to the array called filled array. Look at the value that is in position number 0, which should be the 10, and then store that in the variable called first value. And so now if I want to, I should be able to hopefully print that out. I cannot type today. There we go. And if I run this very simple example, hopefully we'll see our 10 pop out. There it is. If I want to get the last value out of the array, it's going to be a similar idea. Well, let me make a variable for it since I made a variable for the other one. So the last value is at what position? 0, 1, 2, 3, 4. Okay, so I can put a 4 in here, and that should do the trick, right? Whoops, that's not what I meant to do. There we go. So hopefully this will travel to whatever value is at position 4, this 11, and stick it inside of this variable and then print it out. Okay. Cool. Everything seems to be working all right. However, let's come back up to this array that I made here, and you know, what happens if I do something like this? So all I did was I added another value to this array. So now instead of having 5 values, it has 6 values. How do we feel about this down here now?
The first one is good.
This feels okay still, right? But this, I don't feel so great about that anymore. It's not the last value anymore, right? This is not the last value. I'm telling you that it's called the last value, but this actually isn't the last value. I think this is a good time to reiterate the fact that instead of typing that number in, we can actually more accurately compute that for any given array. So I can say something like filled array dot length minus 1. So this is going to give me the length of the array, which is in this case going to be 6. When I subtract 1 from that, we said that the last index is always going to be at the size of the array minus 1, correct? So this should get me to index 5, right? Which should pull out that 0. And if I run this again, we'll see, okay, yeah, there's the 10 and there's the 0. And the nice thing about writing it this way is that if I come up here and I add more, right, more numbers, so I just added a whole bunch more values, well, this still works. Do you see the point I'm trying to make here? This code is still accurate, even though I added those values. You know, there are, what, 10 values in this array now? And so this will properly compute that it needs to pull, to get the last value, it's going to pull it from position 9, index number 9. So I think this is a much more, you know, flexible way of accessing the last value in an array than trying to use the number. In fact, I'll run this one more time just to prove to you that it works. Let me show you kind of, so it did pull the 15. Let me show you the opposite. What happens if I shrink this array? What happens if I take some stuff off? So now there's only 3 elements in it. Okay. Still works. Pulls the 10 for the first one and the 7 for the last one. But what if I tried to do it the old way? What if I, you know, had that 4 in there? That's how I had it originally, right? I just had the number 4 in there. So what's going to happen now? Well, there's only 3 things in the array. There aren't even 4 things in the array. This is a problem. And this is what you'll see whenever you do something like this. This is a very, very, very common problem, especially when dealing with arrays. So while this is probably frustrating, especially if you run into it on a homework assignment or something like that, we can actually look at this and try and understand what it's telling us. It's telling us right here, array index out of bounds. I see that stated right here. That's quite literally saying that you've gone off the end. You tried to access a number that doesn't exist. There are 3 things in this array, and you tried to access something at position 4. In fact, if I scroll over here a little bit, it'll tell me, right? Index 4 out of bounds for an array of length 3. So it's saying you can't, there's nothing at position 4. You went out of bounds. You went too far. Not only that, but this right here with the :17, that's actually quite literally showing me what line number the error occurred on. And if I click it, it'll take me directly to where the error occurred. So now I know that in order to fix this problem, I either need to fix this line of code, or it's possible that the error isn't actually on this line. It's possible that maybe it happened like right before this line of code, but at least I have a general ballpark, right, of where the problem is and where I need to start looking to fix it. So I think that's a really, really important skill as programmers to learn how to do is don't panic when you get these kinds of messages. Errors are going to happen. We're humans. We make mistakes all the time. So listen to what the computer's telling you when you make a mistake and try to figure it out. There's information here, and you can use this information to try and help you figure out the problem. In this case, you know, I'd say, oh, clearly that 4 is no good. I need to say, you know, filled array dot length -1. Or a lot of times some people will forget to do the -1, right? Same problem's going to happen if I try to run this. There is nothing at that position. So, you know, if you see that problem, you'll be like, oh, right, it's -1. I got to remember to subtract 1 from the length. Otherwise, I'm going to go too far. Any questions about this piece? So this is retrieving values out of an array. Before we move on to the next question, I want to talk about the opposite. What if I want to put something into an array? So that's something that we want to do as well. In fact, remember that we created this array up here that is empty. I keep saying that word empty, which is kind of true, but a little bit misleading. Does anybody remember what's actually inside of this array when we first created it? If I looked at that array, what would I see? Zeros. It's going to be filled with 10 zeros. So empty, okay, yeah, but it's actually got 10 zeros in it, which maybe that's what I need. Probably not, though. I probably need different numbers in there. So how do I actually replace one of these zeros with another value? Well, it's the same process, but in reverse. This is how I extracted something out of an array. Notice that it's on the right-hand side of the equal sign. If I want to put something into an array, I'm going to do that part first. So I'll say, oops, not filled array, but practice array. Practice array at position 0 is equal to 10, whatever number you want, right? Take that 10 and put it in the array that's called practice array at the index of 0. So whatever was there before gets erased, and now position 0 in this index should have the value of 10. In fact, we can even verify that by just putting another print line right after this that prints out, you know, practice array at position 0. We should be able to see that's the 10 that came out from this line. The first 10 is from this previous example. So we can put stuff into arrays, we can take stuff out of arrays. But notice that I've only ever touched individual values so far. So let's talk about the next question. Actually, let me stop real quick. Any questions on this piece before I hop down to question number 4? Any questions about what we've covered so far? All right, let me hop down to question 4. What coding structure is used to traverse arrays? It's one that we talked about a lot, actually, just last week. What am I going to use to... Well, first off, maybe we should pause for a second and say, what the heck does it mean, traverse an array? What does that mean? To traverse an array. What am I doing? Traverse in English means I'm moving somewhere, point A to point B. In this context, it means that I'm going to visit each value of the array. So when I say I traverse an array, that means usually I'm going to start at the very beginning of the array and look at every single value in that array. Or if I wanted to, I can actually do it backwards. I can start at the end of the array and go backwards towards the beginning of the array. But that's a traversal, whether I do it forwards or backwards, right? A traversal is going to visit each and every value that exists within this array. So what coding structure that we've talked about in this class are we going to use to pull that off? Anybody remember? What did we talk about last week that allows us to do repetition? Loops, yeah. I heard somebody say for loop. You can use a while loop to traverse arrays. Actually, any loop will do the job just fine. I'm going to show you actually a slightly different kind of loop a little bit later on, but a for loop works really well with arrays. I am almost always going to use a for loop if I need to do an array traversal. And to understand why we might want to do an array traversal, let me just show you this real quick first. If I say system.out.println practice array, right? This seems like intuitively it should just show me the whole array, right? I didn't say give me a specific element. I just said show me the whole thing. Show me what's in this array called practice array. But if I run this program, you'll see that this that I've highlighted, that's actually what I got back from that print statement. That's probably not what I wanted. Maybe not what you were expecting. This is not the contents of the array at all. This is information. It's just not information that's particularly useful to us. If you want to know what this is, this number right here is quite literally where on your computer this array is being stored. So your number probably looks different from mine. I would be very surprised if you see the same number there that I do. But it's quite literally a physical location in your computer where this array can be found, which is mildly interesting perhaps, but not very useful. Not very useful for us. What I want to see is the contents of the array. So in order to do that, we have to do an array traversal. That is a required step. And I'd like to show you the way that I would do that. This loop that I'm writing right now, in the process of writing, is one that I have written, I can't even tell you how many times. Anytime I'm working with an array, right, this loop is always something that's kind of in the back of my mind because it's such a common way, such a common tool that we use for array traversal. I'll say practice array dot length and then I++. So I here is representing my loop variable. Why are you upset? Did I make a typo? Oh, I'm sorry. I needed to say I is less than practice array dot length. This needs to be a Boolean expression, and I screwed it up. It happens. So then inside of the loop, the simplest way to show this off is to just print out the contents of the array. Notice what I'm putting inside the brackets this time. I'm not putting 0. I'm not putting length minus 1. I'm putting I. But think about what that means. I is going to start at 0. That is our first index. It is going to count up by 1 until it hits the length of the array. It will never be exactly equal to the length of the array. Notice it's strictly less than. So if the length is 10, then 9 is less than 10. That means 9 works for a value of I, but 10 is not less than 10. That would actually quit the loop, and that's a good thing. There is no position 10 in an array with length 10. So this is what I would call an array traversal. Anytime you want to print out the contents of an array, this is it. Just replace the name of this array with whatever array it is you want to print out. This is it. This is how you do it. This is how you print out the contents of an array. And I can prove that to you by running this code and showing you that, here, let me put in a little message so I know what we're looking at. Printing array. All right. So here's where it starts printing the array. The first time through the loop, it's printing out the value of position 0. The second time through the loop, it's printing out the value of position 1. And you'll notice that, for all of the ones afterwards, it's 0 because that's what happens when I create a quote-unquote empty array. It just fills it with zeros, and if I want it to be something that's not 0, I have to say what that is. If I want to do the other array, let's print out the contents of the filled array. I just have to replace the name of the array like this. So it did say practice array, now it says filled array. I can run this again. And here we can see the contents, 10, 9, 7. I'd like to do one better though, and just really make sure that you all understand what's going on with this process by walking through it in the debugger. I love showing stuff off in the debugger, showing how stuff works, and this is such an important concept. I think it's really important to understand how this little chunk of code is working. So I've set a breakpoint on my line 26 where I have the loop. And I'm going to start this up in debug mode by clicking the little bug up here in the corner. And when I get to the loop, before I even look at this loop, I'm going to come over here and take a look at my variables window, and you'll notice that I have variables in here for my arrays. What do those look like in the debugger? Well, you can see that it says filled array, but it doesn't really show me what's in it. If I want to see what's in it, notice that there's a little arrow over here, and if you click on that, now I can actually see the contents of this array. It's telling me that in position 0, I see the value 10. In index 1, I see the value 9. And in index 2, I see the value of 7. So now, if we shift our focus back to this loop, right, and start stepping through this one at a time, Notice that the first trip through the loop, I is equal to 0. So when I gets plugged in here, it's going to print out whatever value it finds at position 0, which should be the 10. And there it is. There's the 10. Now I'm going to bump I up 1. I is now 1. And now it says, all right, plug I in here. Print out whatever value is at that position, position 1. And that should get me the 9. I bump I up one more time. I is now 2, right? Prints out whatever value is at position 2 to get me the 7. And now think about what happens. It's going to bump I up one more time. I is going to be equal to 3. But remember, after it does this, it checks the condition. So it's going to say, is 3 less than the length of the array, which is also 3? The answer is false. No. So at this point in time, the loop is over, which is a good thing, right? If I tried to keep going, I would have run into an index out of bounds exception like we saw earlier. So this loop right here is the classic for loop that is used to do array traversals, to print out not just to print out the contents of the array, but anything I wanted to do with the array, right? Maybe I want to multiply all the contents of the array by 2. I would start the same way and just switch this statement up a little bit, right? If I wanted to multiply all the contents of the array by 2, I could say filled array at I is equal to filled array at I times 2. Take the value that's in the array, multiply it by 2, and then put it back in the array. Right? Now I've got an array traversal loop that will multiply all the contents of the array by 2. I mean, the possibilities are really endless, right? Is everybody with me so far? Are there any questions about this little chunk of code here? Definitely put a star next to it in your notes or make note of it. One that I'm going to use all the time, very often. I'm actually going to show you another way to do this using a slightly different loop. So last time I showed you for loops and while loops. This is going to be yet another kind of for loop. It's often referred to as a for each loop, or you may hear it referred to as an enhanced for loop. I don't like that name personally. I tend to use the word for each loop. But the way that it works is a little bit different. For each loops don't have 3 pieces. They only have 2. They only have 2 pieces. So I would say something like for int value. This first part is always going to be a loop variable declaration, followed by a colon, followed by the name of the array that I'm interested in. So I'll just use filled array. Notice that I'm not using the square brackets anywhere inside of this loop. Right? That's kind of the difference between using this style of for loop and using this style of for loop. This I am iterating via index, starting at index 0 and going all the way until the very last index of the array. This loop, for each loops, leave the index out of it. They basically say, I don't care about the index, I only care about the actual values. I just want to see the actual values. So just like before, I'm actually going to set a breakpoint for this loop and walk you through this one as well. I turn my old breakpoint off on line 26 by double-clicking it to turn it off. I set another breakpoint here on line 30 on my for each loop, and I'm going to run us through the debugger one more time here to show you that, okay, I'm about to step into my for each loop for this filled array. Oh, look, you can actually see it successfully got multiplied by 2 as well. That's kind of cool. So here's my values for my filled array that got multiplied by 2 from before. The first time I step through, take a look at the value. Value is 20. It's not 0, right? It's not the index, it's the value. So arrays have 2 sets of numbers that we care about. The indexes that go 0, 1, 2, 3, 4, 5, that's always true. The index always, always, always starts at 0 and counts up. And then the other set of values that we care about are the actual values themselves, the numbers that are stored in the array. These can be anything and probably will not be 0, 1, 2, 3, 4, 5, although it's possible. But they can be literally anything, depending on what problem we're trying to solve. So the first time through the loop, it just takes on the first value of 20. The next trip through the loop, it's going to take on the value of 18, and I get that value printed out. And then the third time through the loop, it's going to take on the value of 14 and print that out. And then notice I don't have to compare it to the length or anything. The for each loop just knows, okay, I did all three values, now I'm done. And next time we step through the loop, it's over. The loop is over. So I like to kind of compare and contrast these two approaches. I think it's good to know them both. They're both handy in different situations, but this way only works if we don't care about the index. If I need the index, if the index is required in order for me to solve whatever problem it is that I'm trying to solve, I have to do it this way. And some people interpret that as meaning that it's, quote unquote, safer to do it this way, right? And that's kind of true. You'll never run into a situation where this type of loop will not work. This type of loop will always work for traversing an array and doing what I need to do. There might be some types of situations where this style of loop, a for each loop, will not work. It will not allow me to do whatever I'm trying to do. Specifically, if the index is important, then this isn't gonna let me accomplish anything that I need to do. But why use this type then? People argue that it's more concise, it's more simple, it's more straightforward, right? It's less complicated because if I can leave the index out, it's fewer places for me to make mistakes and make errors and things like that. In practice, it's up to you to make the choice, right? You can just say, I hate for each loops, I'm always going to do it this way, and that's fine. That's actually okay. Or maybe you like for each loops and you want to try and use them a lot. That's also fine. Just be aware that there might be some cases where for each loops just aren't an option, and you're going to have to do it this way. Before we move on to the next question, any questions on this one? Yes?
So, if there's like a specific, so this one exercises, is like print out only like the values of the odd indices. You wouldn't be able to use it for each question.
That's correct. If I only wanted to print out the values at index 1, 3, 5, 7, for example, that's what you said, it would have to be this style of loop. I think you could maybe do it this way, but then you would end up having to create an extra index variable up here, and it kind of defeats the purpose of using the for each loop. So maybe impossible is a strong word, right? There's almost always workarounds and things that you can do. But if you know that you need the index, then that's the loop to use for sure. If you're not sure whether you need the index or not, honestly, that's probably still the loop to use. Because then you've got it if you need it. If you know that you don't need the index to get the job done, then this loop is considered to be more friendly, more easier to read, easier to understand, less complicated. So consider that as an option. But like many things in coding, there's always going to be different ways to get to the same place. Yeah?
Can we traverse an array by just saying like system.out.println?
I'm sorry? You're trying to do what now?
Yeah, like print line. Yeah, just build arrays.
Okay.
Print the array.
I literally just went through this in class a few moments ago, so when I post the video, you can go back and take a look at it, all right? Yep. The answer is no. There's a reason why I jumped through all these hoops, and I showed that to you, so you can take a look at the recording later, catch up on that. Any other questions on this before I move on to the next question? All right, so arrays themselves are somewhat complicated. I think even with just what we've talked about so far, students are somewhat intimidated by using arrays. However, there's still more. There's still a few things left to talk about. We can actually take our arrays and make them two-dimensional. What does that mean? What is a two-dimensional array? Yeah.
Sorry, this is a question.
Sure, yeah. Go ahead.
I know we said that like for specific arrays we can't add to the size of them once we've already declared what their size is. And I guess this is less of a question for like arrays specifically, but can you delete variables and things like that in code, or do they just kind of exist there whether you use them or not?
So no, you don't really delete variables. I mean, if I don't need this in my code anymore, then I delete it and I take it out of the code, right? I'm not just going to leave variables in my code that I'm not using. So first off, there has to be a justification for me to make the variable in the first place. But to kind of get more to what you're asking, if I decide that I'm done with a variable and I don't want it anymore, there is no way to say throw it away. The computer does that for you automatically. The computer actually checks to see, oh, they don't use this variable anymore after this point. I'm going to throw it away, and it does it behind the scenes. You don't even need to worry about that. That's not a thing that programmers even have to pay attention to. Yeah. Good question, though. That's actually not true for all languages. It's true for the big ones, though. Java and Python, and all of them do it that way. Yeah. Some of the older ones don't, which if you take 332, you'll find out in a couple of years. All right. Back to this question. What's a two-dimensional array? How does a two-dimensional array differ from the arrays that we've been using so far? Can somebody tell me? I would describe the arrays we've been using so far as a one-dimensional array. Yeah, I see a hand.
In like a two-dimensional array, you store things in rows and columns.
There we go. Yeah, perfect. Two-dimensional array, as its name implies, has two dimensions. So the arrays we've been using so far, I would describe as one-dimensional. They represent a row, a single row, or maybe a single column, right? If this were a linear algebra class, I would call them a vector, right? But it's not. It's a computer science class, so we call them arrays. If I say something is two-dimensional, that means it has a length and a width. So if I want to create a two-dimensional array of integers, for example, or let's use a different type. Let's use doubles this time. If I want to create a two-dimensional array of doubles, I have to say double bracket bracket. So two brackets means that it's a two-dimensional array. And just like before, if I want to make an empty double array, I can by saying, new double. But I have to say bracket, bracket. And then inside of these brackets, I have to provide numbers where these numbers represent the numbers of rows and columns that I want for this array to have. So I'm not making a single vector anymore. I am making a grid. I am making a rectangle. Something that is two-dimensional. Which does this represent? Rows or columns? Does the 3 represent my rows or my columns? Rows. Yes, the first number is always rows. The first number, the first bracket is always rows. The second number is always columns, and it's angry at me because I forgot to give this variable a name, right? I got too excited about making it and I forgot to give it a name. So let's give this a name. 2D. Yeah, I'll just call it 2D. That's good. Okay? And so this next question, how is data accessed within a two-dimensional array? How do I put stuff into a two-dimensional array? How do I get stuff out of a two-dimensional array? Well, if I want to put something into a two-dimensional array, right, in the past, with the examples we saw before, I would just say, this at position 0 equals something, but this is a two-dimensional array, so I have to say bracket, bracket. I have to give you two numbers. One index is not enough for a two-dimensional array. I have to give you two indexes, one for the row and one for the column. Yes? Question?
So if you just got rid of the 3, just had 0 there, and you said multiply by 2, would that apply to the whole row?
Yeah, I wish it would. The question was, can I just grab the row and multiply by 2 and do something like that? Unfortunately, no. Yeah. So it's kind of a similar thing that we saw before. If I want to manipulate the contents of an array, I have to traverse the two-dimensional array and visit each element one at a time and do the thing that I want. Yeah, it's a good question, though. Back to this question at hand. If I want to put something into an array, right, this says put it at row 0, column number 3. So I'll set that to be 7. Or it's a double, so I can make it, 7.5 if I want to. That's also fine. If I want to do the opposite, if I want to say, you know, get a value back out, then I need to say 2D, again, bracket, bracket. Which value do I wish to extract from the array? I'll extract the same one that I just put in. And I can show you that once I print it out, it should be the 7.5. This puts the 7.5 in the array, position 0, 3. This extracts that 7.5 back out of the array and puts it in a variable, which I then print out. The important thing here is that I need two indices, one for the rows and one for the columns. So if we take a look at this, that seemed to work the way that I intended. If we want to create a 2D array that has stuff in it already, we can do that too. So I can say, actually, let me make a Boolean 2D array. Why not? A Boolean, I'm running out of good variable names here. Another array, I don't know. So in order to make a two-dimensional array like this, instead of using one set of curly braces, I'm actually going to use multiple sets of curly braces. And inside of here, since I'm doing Booleans, I have to do trues and falses, right? Oops, I forgot a comma there. And a comma here. So the outermost brackets are for the entire array. This set of brackets will be the first row. Right? This set of brackets will be the second row. So by the time this array gets created, it's going to have 2 rows and 3 columns. Does everybody see how I got there? Right? Any questions before we tackle this last review question here? So the last one then is, how do we traverse two-dimensional arrays, right? So before I showed you this nice nifty, int I equals 0, int I is less than. Well, here we already kind of run into a problem, right? What does, what is, another array dot length? Well, wait a second. When all I had was a one-dimensional array, saying dot length seemed pretty easy to figure out. It's just the length of the array. But this is a two-dimensional array. So what does dot length tell me in a two-dimensional array? Does anybody know? Yeah, in the back. It's actually not the row length, but you're close. Or maybe I interpreted your answer slightly incorrectly. It's the number of rows. For a two-dimensional array, this tells me the number of rows. The number of rows that I have. Okay, so that kind of makes sense, right? And here's the loop that I had before that worked very good for our one-dimensional arrays, but that's not enough for a two-dimensional array. We actually need a second loop. So this one is going to handle all of the rows, but I need a second loop to handle the columns. And so this is a very classic way of doing this. The outer loop uses I. Notice that this loop is inside of this loop. What's it called when I have a loop inside of a loop? Nested. Good, yeah, good. So instead of, using I here, I'll use J, and I'll say J is less than, well, I can't say another array dot length here, right? That's not going to work. This won't work, because that tells us the number of rows, and I'm trying to write a loop that goes for the number of columns. So how do we get the number of columns out? This is a tricky one, and one that trips a lot of people up. So in order to get the number of columns out, I'm going to say bracket 0 here. Think about what this means. This is a two-dimensional array. That is true. If I say bracket 0, that says get the first row, get the 0th row of the array, and tell me what the length of that row is. The length of a row is the number of columns, right? If there's 7 things in that row, I know there are 7 columns in my two-dimensional array. And I think I should also note that while it is possible to have arrays that come in various shapes and sizes. The vast majority of two-dimensional arrays that you're going to see, and all of the two-dimensional arrays that you see in this class, will be rectangular, meaning that all of the rows will have the same length. None of the rows are going to change. It is possible to have rows of differing lengths in a 2D array, but we're not going to go there in this class. Yeah?
How would you be able to get the length of a column?
Well, the length of a column is just the number of rows, right? So this tells me the length of a column. Yeah, it's a good question. Yeah. Also note the order that I did this. I did rows first and then columns. That is a pretty natural way of doing it instead of columns first and then rows. Although you can do columns first and then rows if you really want to. And some problems, maybe it would be better to do that. But let's kind of work through this one real quick. I'm going to try and print out the contents of this array, right? Print line. So inside of here, I need to say another array. But remember, if I want to print out something from this array, I have to give two values. So I represents my row. J is going to represent my column. So inside of the first pair of square brackets, that represents the row that I'm on, so I'm going to use I. And the second pair of square brackets represents the column that I'm on, which is J. So I'm going to do something like this. Let's see if this works. Let's try this out and see if we can see the contents of our array get printed back out for us. And okay, I mean, there it is. But notice that, it doesn't really look the same, right? It should be in a grid. Or at least that's kind of how I'm envisioning it, is it should be in a grid. It's a two-dimensional array. It's a rectangle. This doesn't look like the rectangle. This should be the first row, these three values, and this should be on the second row. Can I tweak this code to make it look more like the array that's in there? And the answer is yeah, absolutely we can. Let's start by considering that I don't want this to be on a different line than this one, right? I want it to be on the same line. I want all three of these values to be on the same line. I only want to move down to the next line when I hit the end of a row. Which part of this code represents the end of the row? Where in this code do I want to go if I'm at the end of a row? Or maybe another way of saying it is like, okay, this loop here represents the rows, right? So if I want to do something at the end of the row, I'm going to do it at the end of this loop, since this loop represents the row. So everything that I'm telling you says, all right, let's first take the println off, because I want these to be on the same line. If I run this, we'll see that, okay, instead of going down, it's going across now. But well, a couple things. I need spaces. That's actually not too hard to do. Plus a space, all right? Oh, whoops, that needs to go inside the parentheses, sorry. We'll just concatenate a space on there to make sure we get that. But okay, I need this to move down. So what do I need to do? At the end of a row, I'm actually just going to do a println with nothing in it. That's just going to move me down to the next row. So when I start printing out those contents, they should hopefully appear on the next row and not the same one as before. So now when I scroll up, I can see, oh, this looks just like the 2D array that contains those values. Question?
Yeah, this is kind of like a bit more like general, but when you printed that out, what type would that be? Is it string since you have to use concatenation, or would it still be boolean?
Yeah, that's a great question. The question is, what type is it when I print it out? So to answer your question, it's definitely a Boolean going in, because I can see it right there, very clearly listed as Booleans. But whenever I pass something into print, part of what the print function is doing for us is turning it into a string, so we can see it. I mean, yes, but not in the sense of our code, right? Like I am looking at strings down here, yes. But that's all happening inside of here. I don't actually see that happening. That all happens behind the scenes. Does that kind of make sense? Yeah, that's all happening under the hood. That's not something that we need to worry about. Back to this example. I want to run you through this one in the debugger as well, just because I think it's so important. Actually, this example here is kind of like the one I showed you before, where I really think you should put a star next to it. You're going to need this nested for loop structure at some point in time, either on the upcoming homework assignment or in the studio or the exam or all of the above, right? You're going to see it. It's going to pop up. So let's make sure we really understand what's going on with this before we move on to the next thing. I set my breakpoint here on line 47, the beginning of the loop. And because this is a nested loop, it's important to understand how this motion is happening, right? Let's take a look. Oops. So I forgot to turn this breakpoint off. My bad. I can just hit the resume button here, and it should. Oh, well, let's double click it to turn it off, and then hit the resume. Okay, there we go. Had to turn the old breakpoint off. Now I'm on the nested for loop that I care about. Pay attention to especially these variables I and j and how they are progressing. Notice that they both start at 0. So the first element that I access in the array is going to be at position 0, 0. And in my brain, right, my mental image of the array says position 0, 0. That's the one that's at the top left corner. So the top left corner of my array is position 0, 0. And as I start stepping through this code, you'll see that, okay, I has started at 0. Once I go into the second loop, j starts at 0. Okay? So the first element that I'm going to see is whatever is currently living at position 0, 0. But where do we go next? Where do I go after I do that? I'm going to print out, the true value that I see at position 0, 0. Where do I go next? Well, notice that I'm still inside of this loop. This is a nested loop, which means that this loop here has to finish entirely, has to do the whole thing before I'm going to go back up here and revisit this one. Or in other words, I is going to stay constant, and j is going to go 0, 1, 2, 3. And then once I get through all the j's, then I is going to go up, and then j is going to go 0, 1, 2, 3 again. Right? So the next place that I visit, I is going to stay at 0. J is going to move up to 1. So I was at the top left corner. I'm now at the one that's directly to the right. I'm on the same row, but I've shifted the column over 1. So the next value that I see get printed out is right there, directly to the right. And then we're still not done. There's still more values to see. So now I'm at position I 0, J2. So that's going to be all the way over, in this example, the top right corner. Correct? So we print that value out. There's my first row. This loop is now going to be finished. I've gone through all 3 values of j. This condition is about to evaluate to be false, which means we're going to jump down here. This says, all right, move down to the next line. I'm about to do another row. I'm about to do the next row. So it moves down to the next line. And then we're going to continue on. I was 0. Now it's going to be 1. I did row 0. Row 0 is finished. I'm moving on to row 1. J, however, is going to restart. It's going to start back over again at 0. Print out the next row. So there's the 0 value in row 1. There's position 1, 1, row 1, column 1. And then finally, row 1, column 2. That's the bottom right corner in this example. It'll actually put one more blank line on the end, although that doesn't really matter because after this, there are no more rows. We've done both rows that we have, so this loop is over, and we are done with our nested for loop, right? But this is definitely a bit more complicated than just one loop by itself, having this loop inside of a loop. What I want you to notice, though, is that the way that I've written this, by writing this loop for the rows and this loop for the columns, how am I traversing this 2D array? I'm starting at the top left, going down the row, then going to the next row. Then if there was another row, I would go down to the next row. I'm doing it left to right, top to bottom, just like I was reading a book. Just like if I was reading a book, right? left to right, top to bottom. I'm going to visit each and every element in this two-dimensional array from the top left to the bottom right, in that order. Does that make sense? It's a very, very important takeaway from today's class. If there's any questions, if you want to see me go through it again, explain anything again, I'd be happy to. Let me know if you're feeling confused or stuck. Okay. That was all the kind of review questions that I had for today. So for the remaining time that we have, which is only about 20 minutes, we should be able to do at least one or two of these exercises. I was really hoping to get to one or two of these exercises. Does anybody want, before I open one of these, which I have one in mind, was there any from the prep work that somebody wanted to see me walk through? I'd be happy to spend some time on that. Yeah.
I just had a question on the one about nested loops for 2D arrays. It has the like command return at the end. Like it's like when it's categorized by the largest, it says like return largest.
Do you remember which one that is? Which example?
It was within like, the assignment on the thing of like the reading.
I'm not sure. Within the assignment?
Or within like the reading on the actual.
Oh, it was one of the reading examples?
Yes.
Maybe we can chat about that after class. Yeah, sorry, I don't have those on here right now, so it's not easy for me to talk about those. But I'd be happy to chat with you after class. Are there any from these prep work problems you'd like to see me go through? Or I can, yeah.
Could you go over one of the like exercises, or do you not have those?
I have all these exercises. If there's one in particular you wanted to see, yeah, be happy.
Could you please do the count 7 one?
This one?
Yeah.
Okay, be happy to. I'm glad you picked a 2D array problem. I think, well, I mean, 1D arrays are kind of tricky on their own, but the 2D arrays are an extra level of tricky on top of that. So definitely happy to do this. This code, and actually this is very similar to one of the ones that I was going to ask you to do anyway. So this is a great example for us to walk through. This code wants us to go through and count how many times the number 7 appears in this two-dimensional array. So this 2D array happens to have the same number of rows and columns as our previous example, right? I've got 2 rows with 3 columns. The way they've spelled it out makes that a little bit harder to see. I actually kind of like to, keep it somewhat rectangular when I do it, so I can clearly see, oh yeah, this is a 2 rows by 3 columns kind of deal. So let's go ahead and walk through this step. I mean, hopefully your brain is thinking, we just used that nested, that nested for loop thing. It seems like since we're doing 2D arrays, that might come in handy. And that's true. Anytime you see a two-dimensional array, I want your brain to think, maybe nested for loops here. Be careful, because the answer isn't always going to be nested for loops, right? There are some situations in which that's not the right path to take, but in a lot of them, using that nested for loop, one for the row, one for the column, is going to be the right thing. And that happens to be the case here. So I'm going to come over here, and I'm just going to grab these 2 for loops. Why reinvent the wheel? I'm just going to grab these 2 for loops and swap it out for the array name in this problem. I just copy-pasted those directly from before. And now I just have to figure out how to do what it's asking me to do. It's asking me to count how many times the number 7 shows up in here. What am I going to need to keep track of that count? A variable? Yeah. I know that sounds like a very simple question. It is a simple question, I hope, at this point. I'm going to need a variable for my counter, and I'm probably going to want to start it at 0, right? If I haven't seen any 7s yet, then the counter should be 0. Within here, I know I'm going to see each element. So what I really need to do is check to see if the element is a 7, right? So what construct am I going to use to check to see if the element is 7? I've actually been saying it, if you've been paying close attention. If, that's right. I need an if statement. If the value at I, j, so remember, I represents the row that we're on, and J represents the column that we're on. And if I use this nested for loop structure, I know that this will visit every element in my 2D array. So I just need to check to see if it's equal to 7. We okay? I'm waiting for somebody to yell at me. Please. Double equals. Good. Yeah. Double equals. Classic mistake. Classic mistake. Got to be double equals there. I'm checking equality. I'm not doing variable assignment. If the value that I see at this position is 7, then what do I need to do? I need to increment my count by 1. Or if you're still not quite comfortable with the plus plus, I mean, this is also acceptable. Count equals count plus 1. They mean the same thing. This means the same thing as this. They'll both work. I don't care which one you use. Whichever one you feel comfortable with and understand the best is the one that you should use. And then let's go down here, and just to make sure that we do this properly, we can print out what that count is. It looks like it should be 2, right? There's a 7 and a 7. So it looks like it should be 2. Let's give it a try. Yeah, it is 2. However, I would say that, okay, like that's good and all, but let's make sure that it works for not just this specific example, but for like any 2D array, right? Because you know, there are many different collections in the world, and I don't want this code to be fragile. I don't want this code to only work in certain situations. I want this code to work in as many situations as possible, right? So let's test it and make sure that that's in fact the case. We can add another row. I'm just going to copy this existing row and add it in the end, and maybe I'll make it all 7s just because I can, right? And now there are 1, 2, 3, 4, 5 7s in this 2-dimensional array. And if I run this code again, hopefully it tells me that fact, right? Hopefully it tells me that there are 5 7s, and boom, yes it does. That's great. That's what I want, right? If you run it again and it still says 2, well, that means that, you know, you probably did something like this, where you just say directly in the loop, there are 2 rows. Well, I mean, that's true now, but that may not always be true for all arrays. So it's very much preferable to use the length of the array, the number of rows and the number of columns of the array to specify exactly, and that way it'll work in all situations. Is there a question over here? Yeah.
Sorry, what would happen if we put count plus plus, like the if statement outside of the, like inside for?
You want to do it outside of this? So you just want me to move the whole thing out like this?
Yeah.
So unfortunately that's not going to work because I'm referring to J here, and J does not exist outside of this loop, right? This loop is what creates J. So I can't even run this. It's not going to let me run it. Yeah. It's a good question though, and that's actually, I think, you're kind of hitting on what can be one of the trickier parts about programming. A lot of times people know the code that they need to get the job done, but where does it go? That's not always an easy thing to figure out. Where does the code go? Understanding the flow of the program is very important for making that determination. If you know exactly the order that things are happening in, then you should be able to figure out where a certain operation needs to happen. But if you're unsure of the flow, then that can be very tricky. Great question. Any other questions on this particular example? Anybody have another example they want to see me go through? We do still have a little bit of time left. If there isn't, then I don't think there's enough time for me to like do the whole give you 5 minutes and regroup because there's only 10 minutes left. But I don't want to stop yet. I want to show you another example. So I'm going to run through this one real quick with the last 10 minutes I have left. This example wants us to first write a program that asks the user how many random numbers they would like to be generated. And then if I say, you know, I want 5 random numbers, then I want to create an array that has 5 random numbers in it between 1 and 10, inclusive on both sides. So, okay, first we need to ask the user how many numbers they would like. So let's say that first. How many random numbers do you want? And now I have to use the scanner, which I haven't set up yet, so maybe I should do that first. I, of course, know how to set this up because I've done it a bajillion times, but if you need to pull this from another file, that's totally okay. That's totally fine. You can copy paste this from another file if you need to. All right, I've set up the scanner. I will say int number is equal to in.nextInt. So far, we haven't really done anything new or anything with arrays yet at all. This is just a simple scanner problem at the moment. But now that I have this number, I need to create an array that has this many things in it, right? And then I need to fill that array with that many random numbers. So in order to create the array, we'll first say, I'm going to make an integer array. It doesn't need to be two-dimensional here, right? One-dimensional is totally fine. So randoms is equal to, I'm going to make it empty to start with, and then fill it with random numbers. So I'll say new int number, right? If the user says they want 10 random numbers, then this line will make an empty array with 10 things in it. If they say they want 5 random numbers, then this line will make an empty array with 5 things in it, right? Everybody with me so far? So now we just need to do the random number part, and I need to generate multiple random numbers, not just one, but multiple random numbers. So to me, that says I need a loop. I need a loop for this. How many random numbers do I want? And actually, where are they going to go? I'm going to put the first one in position 0, second one in position 1. So this is actually, definitely time for one of the classic loops that I showed you. I could put randoms.length here. That's okay. I could also put number here. And I hope you understand why both seem appropriate, right? They're potato, potato in this case. Doesn't really make a whole lot of difference which value I put there. They're both going to be fine. I'm assigning something to the array. So which side of the equal sign is the array going to go on? I'm putting something into the array. So which side of the equal sign do I need to put the array on? The left side. That's right. Assignment statements go from right to left. Take the thing on the right-hand side of the equals and put it in the thing on the left. So if I'm trying to put something into the array, then that means that the array needs to go on the left side of the equal sign. So I'll say randoms at position I, and here's where we have to generate a random number. We have to pick our random number from 1 to 10. Okay. Hopefully you remember from prior classes that math.random gives us random numbers. But what kind of random numbers does math.random give to us?
0 and 1.
Between 0 and 1.
A double.
And a double format, so it could be 0.5. Will it ever give me 1? No. Will it ever give me 0? Yes. It can give me 0. It cannot give me 1. It can give me 0.999999999. Cannot give me 1. Okay? Well, I don't want between 0 and 1. I want between 1 and 10. So there's a little bit of arithmetic that needs to be done. What I'm about to show you can be used to generate random numbers between any range, not just 1 and 10, but any range. Just have to modify the values a little bit. So first off, we need to figure out how big the range is. How many different random numbers am I trying to generate? And be careful, it's not 10. It's 11. It's 11, right? 1 through 10 inclusive. So once I figure out how many random numbers are possible, I'm going to multiply by that. Think about what this does. I always like to think about this in kind of low extremes and high extremes. If math.random gives me 0, then obviously 0 times 11 is going to be 0. If math.random gives me 0.9999999, then that times 11 is going to give me 10.9999999, repeating, right? but never, never, never actually the value 11. Am I off by 1? I might be off by 1, but that's okay. We'll figure it out. Yeah. This is going to be a double. I don't necessarily want doubles. I want ints. So how do I chop off the decimal point? Anybody remember? Casting. Rounding, not quite going to work because rounding could take me up. And I don't necessarily want to go up. I just want to chop the decimal point off. So I'm going to cast it to an int. So think about what that means. If this gives me 0, that's going to multiply by 11, and I'll get just 0, right? If I get 0.5 out of math.random, somewhere in the middle, then I'll get, you know, what, like 5.5 as the double, but then that's going to chop the 0.5 off, and I'll just get 5. If it gives me the highest value it can, which is 0.9999999 repeating, that'll give me 10.99999 repeating, and then this will chop that off. I actually think this might need to be 10 and not 11, but we'll test it in a second and see if I'm off by 1. It's very possible. The last thing that we need to do is consider that, okay, this starts at 0. I don't want to start at 0. I want to start at 1, right? I don't want to go from 0 to 10. I want to go from 1 to 10. So I need to add 1. That takes the whole range and shifts it up by 1. I think I might have been mistaken before. I think this might need to be a 10 instead of an 11, but I guess we'll find out in a second and see. It's an easy fix either way. Real quick, just to test our work, I'm gonna put another loop down here to print out the contents of the array. So that we can actually check it and make sure we're getting the proper values. Let's run it and see. Uh-oh. I accidentally a semicolon somewhere or something. Oh, over here. There we go. Try again. How many random numbers do I want? I want 5. All right, 3, 9, 6, 2, 10. Yeah, that looks good. Let me do a bunch of them just so we can check and make sure it's giving us proper random values. I don't want to see anything greater than 10, but I also do want to see some 1s. There's a 1, yeah. There's a 1, there's a 10. So I think this is working. My explanation was a little off before. I'm sorry about that. We multiply by the range. This is honestly the trickiest part for me to get right. Multiply by the range, and then we add or subtract depending on where we want our range to start at. So if I wanted to generate numbers from -1 to -10, for example, right? I would still multiply this by 10, but then I would have to subtract 10 here to shift the whole thing down. Do you see that? Right? Same range, but then just shift the whole thing down 10 instead of up 1. If I want to generate numbers, you know, between 1 and 50, then I can just multiply by 50 and add 1. Or if I want to generate numbers between 50 and 100, right? I'm going to multiply by 50 and add 50. Because there are 50 numbers between 50 and 100, that's the multiply, and then I shift up to 50 so that my random range starts at 50, right? So just by manipulating these two numbers here, the range, and this one's called the offset, or where the random numbers start, I can use this to generate any random numbers between any range that I want. It's very powerful, and you're definitely going to see that come up again in future exercises, homework assignments, exams, etc. That's it for today. Thank you so much, everybody. I hope this was helpful. I will see you in the labs on Wednesday for studio. Have a great week, everyone.